As a kid, I never understood how money can get out of a machine. How does it make sure everything goes right? How does it keep the numbers correct with such high security, especially when no one is guarding it? Later, I realized that behind every ATM there is a system designed by people like us who care deeply about the smallest possible errors. I am Sham, and I design systems by thinking about how they might fail and how can I protect them from failing. This is a small ATM system project, part of my low-level thinking series. Let's get started. This ATM project is written in C++. You can find the full code on my GitHub, link in bio. The project is built around a few core components. An authentication class responsible for reading, writing, and updating account data. A transaction class that handles basic operations like deposit, withdraw, and balance checks. And finally, transaction info class that keeps a record of every transaction made by the user. All of this sounds simple and fine, but the real question is, what could go wrong in an ATM system? The answer, a lot, and every possible failure leads you to design a better, safer system. Login attempts. When you insert your card into an ATM, it asks you for a PIN. If you enter it wrong 3 times, the card gets locked until the owner contacts with the bank. Why? Because the system must protect users in case their card is stolen. In this project, I limited login attempts to 3 tries. If the sign-in succeeds, the system immediately exits the loop. Withdraw conditions. Here we are dealing with one of the most sensitive things in the world, money. So the system must detect and stop fatal user mistakes, such as entering an amount less than or equal to 0, trying to withdraw more money than the current balance. All of these cases are blocked before the operation is executed. You will find condition that validates the withdraw amount against the user's balance before allowing it. When should the balance be updated? Now imagine user withdrawing money dollar by dollar. Updating the database after every single operation costs more money, increases the chance of errors, creates unnecessary overhead. So instead, I chose not to update the stored balance immediately. I store the balance inside a user info object, perform all operations in memory, and only update the database when the user logs out by pressing exit. At that moment, the final balance is sent back to the bank. But what about concurrent access? You might ask, what if another user logs into the same account while the first session is still active? That could lead to outdated data or even lost money. To prevent this, I log the user session. No other login is allowed for the same account while it's already open. You will also notice that the balance is updated only when the user exits. The user info object is passed by reference, which preserves state across all operations. This was a key design that helped maintain consistency throughout the session. And to wrap up the project ideas, in the authentication class, sign in and sign up rely on simple file input-output. Here is an important trick when updating data in the text file. Unlike databases, you cannot update a specific row directly. Instead, you must read the entire file into memory, modify the target user's balance, write everything back to the file. This approach is simple, reliable, and perfect for learning low-level system behavior. The transactions class handles the core operation, nothing fancy, just clean logic. The transactions info class has 2 main responsibilities: recording every transaction in a text file, reading and displaying transaction history for the user. Each transaction is saved with its date and time, which makes the system more realistic and traceable. The UI is simply a flow of data between the classes we discussed. The system is divided into menus: a main menu for sign-in and sign-up, a transaction menu for account operations, a redirect menu to go back or exit the session. I have also made a separate video explaining how this menu system was designed. You will find the link in the top right corner. That's the project. Now I will leave you with a question. What do you think could go wrong in a real ATM system? Share your thoughts in the comments below. And remember, don't copy this code directly. Use it to generate your own ideas. You might end up with a much better approach. If you find this helpful, subscribe for more. See you in the next low-level thinking project, and happy coding!